set with where there are two elements? Yes, it's our set A, which has got two elements. Any set which has got three elements? Yes, B has got three elements. And then of course set C is infinite. So this is how the set is. This is how you get the subset. This is what is asked in the question. So that's about our question number 1. Now we go to question number 2. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Now this is a law that you have to keep in mind throughout your life, that whenever their statement is false, you just have to give a counter example. And whenever the statement is true, you have to prove it. Why it is true? You have to prove it. That's how you give reasons to these things. So that is being again confirmed over here in this question. So that's how we have to justify. Each statement we have to think, analyze, and we have to get the reasons or write whatever, whether it is true or false and all that. Okay, so let's get across right away. Question number 1 or subpart number 1 says that if X belongs to A, X is an element of the set A and A is an element of another set B, then X belongs to B. I'm not happy with it. It's false. And why it is false? Because it's very fresh in our mind. Somewhere in the exercise on subset we have done this problem. That is why it's quite fresh in my mind. It's false. And I will tell you why. We'll take an example. Okay. We have come across, suppose say, let our X be something like 3. Okay, and let our A be a set, maybe 3, 4. Okay, so does X belong to A? Yes, X belongs to A, yes. And A belongs to B. So let us define B. B is another set 1, 2, 3, 4 and 5. I hope you remember. This was done somewhere earlier in our exercise. So these are things. Now if this is the case, here we have all this considered here. X belongs to A, yes. A belongs to B, yes. Then X belongs to B. Does this X belong to B? No. 3 is not belonging to B. 3, 4 as a set is belonging to B. And 3 as a single element doesn't belong. Now, so that means our statement is false and we have given a counter example. That is what we are supposed to do. So you'll write here 3 does not belong to B. And that is our reason. And that means that's our counter example. Let things not be very overcrowded. Right. So then we come across this one. If A is a subset of B and B in turn, A is a subset of B and B in turn is belonging to some C, then you have to, then whether A is belonging to C. Again, that's a false statement. Let's see how. A is a subset of one set B and B is belonging to some set C. Okay, and then whether A is belonging to that set C. So we have, say, if we could call A as some singleton one, and it has to belong to B. So let B be 1, 2, and this is belonging to C. They say. So let C be having, B is belonging. So maybe 1, 2, and 3. Suppose. So it is satisfying everything. A is a subset of B? Yes. Yeah, A is a subset of B? Yes. And B is there inside C? That is also correct. Then they are asking whether A is there inside C. They are asking whether A is there inside C. The set A, whether it is there inside the set C? No. We find that the set 1, 2 as a set is there inside C, but the set A, that means singleton 1, is not there in C. So that is why it's a false statement. So you have to show that. But singleton 1 doesn't belong to this set. That is set of 1, 2 and 3. So that is why we say that the second statement is false. This is about the second statement. Then we come across the third. If A is a subset of B and B is a subset of C, then A is a subset of C. That is the third subpart. They say that if A is a subset of B and B is a subset of C, then A is a subset of C. That's a true statement, and because it's a true statement, we have to give the proof of it. Now, when we come across this, we are also coming across a new style of working. All this time, we were using all our set theoretic concepts and we were doing our work. We have never seen how to show that one set is a subset of another set. There is a strategy that we need to follow. Whenever a set is a subset of a set, there is a kind of a strategy that we need to follow. In order to show that A is a subset of C, what we have to do is, you have to start with some element X belonging to A. You have to start like that. And with whatever given work is there, you work it out and show that the same X is belonging to C. So that is what you have to do. Starting with X belonging to A, you have to show that this X is belonging to C. Then only you can give the proof of it. Now what I will do is, this proof probably, I don't know whether there will be enough place. Yeah, I will write the proof here. Let's write the proof here and see how it is. What we are doing is, we are starting with an, as I said, whenever we have to show that A is a subset of C, we are going to start with an element in A. So let's make the beginning right away. So in the proof, we are going to take let X belong to A. So we have an element X inside the set A. See, we know some data about A. What do we know? That A is a subset of B. A is a subset of B means A is inside B. Something like this. You can visualize. This is A and this is B. So if X is there here, automatically X is there in B also, because X is A is a subset of B. A is sitting inside B. So if X is there in A, it is definitely there in B. Why? Because it's a subset. So therefore you can write, therefore X belongs to B also. Why? Because A is a subset of B, and as I showed it in the diagram, if X is there in A, automatically it is there in B. So you have got X belonging to B. Also, they have told us that B is a subset of C. Same idea. If B is there, there is a C here. If there is some X belonging to B, then this X is there in C also, because automatically, it's a smaller set. It is going to the bigger set also. Therefore, X will automatically belong to C also. Why? Because B is a subset of C. Whatever is there in B will be there in C also. Whatever is there in the smaller collection will be there in the bigger collection. So like that, X is there in C. What has happened in this process? Starting with X belonging to A, we have got X belonging to C, and that is exactly what you want to show a subset. So what has happened is, we write like this. Thus, for starting with an X belonging to A, we have reached X belonging to C. Therefore, A is a subset of C. This is how we show our proof of. See, this is a new thing for us. We have not done this till now. We have not shown that one set is a subset of the other set. This we are doing it for the first time, and 3-4 times in the exercise we will be using it, and somewhere later also we will be using this concept. It's a very powerful concept. But set theory has been evolving over the years, and lot of concepts have changed, and we have started using different ideas to prove things, and this method has it is used less. We use other set theoretic concepts to prove things. Earlier this was used very rampantly. Now we use it little less. We use other concepts to prove more rapidly. So that is about the third subpart. Now we are going to the fourth subpart, and fourth subpart they are asking us whether it is true or false. In the fourth subpart, maybe I will write it so that there is no confusion. This is the fourth subpart, and fourth subpart, if A is not the subset of B and B is not the subset of C, then A is not the subset of C. Not necessary. False. It's not necessary. So I'll give you a counter example for that. For fourth, I have a counter example, and the counter example, it says that A is not the subset of B. So maybe my A is singleton. We'll take smaller set now. Why to take bigger sets and get confused? Small sets. We won't get confused. B, let it be 2. Is it clear to us that A is not the subset of B? Yes, A is not the subset of B. Then B is not the subset of C. So let's take our C as something like 1, 3. It's very clear to us that A is not the subset of B and B is not the subset of C. They are not subset. That is what we require. Then A is not the subset of C. No, A is a subset of C. Right. That is why we call the statement as false. But A, that is, if you get confused like that, singleton 1 is a subset of 1, 3. That is, A is a subset of C. So that is why we say that that statement is false. So you can, there are cases, if A is not the subset of B and B is not the subset of C, there are cases where A can be a subset of C. So that is why if you tell a statement like that, it will be a false statement, and we give a counter example. So this is the counter example. Now we come across the fifth subpart and see what it says. Let's see what the fifth subpart says. Maybe this is the answer for the fifth subpart. If X belongs to A, X is belonging to A, and A is not the subset of B, A is not the subset of B, then X belongs to B. How should that be? X is belonging to a set A, and A is not the subset of B, then X belongs to B. It's a false statement, and therefore we'll have to have its counter example. We'll take a set A and we'll take a set B. X should not be, so you could have maybe A as say 1, and say B is not the subset of B, so maybe B is singleton 2. X belongs to A, that means 1 belongs to A. Then 1 belongs to B, 1 belongs to A, but 1 doesn't belong to B. And this is quite trivial, it's very understandable. So something that is belonging to A, and if that is not a subset, automatically that element cannot belong to B. That cannot happen. So that is what we are writing here, but 1 doesn't belong to B. Maybe we can give an example like that. So that is about our fifth question, sub-question. Now we come to sixth sub-question, and in the sixth sub-question they say, if A is a subset of B and X belongs to B, bigger set, X is belonging to the bigger set. Oh, some question mistake is there, let's check. X doesn't belong to B, yeah. If X doesn't belong to B, then X doesn't belong to A. So they say that if you have a subset and if there is an element which doesn't belong to the bigger set, then yes, it's a true statement. Now we will first visualize. A is here, B is here. There is some element X which is not in B. So if it's not in B, it has to be outside, right? So there is this X which is outside. Because X is outside, how can it come inside A? Cannot come, it's outside. So that is what they are saying, X cannot belong to A. It's a true statement, and we will give the proof, right? So for this we have the proof probably. Let's have the proof. See, X doesn't belong to B means, can we say that it belongs to the complement? Given that, see, it's given that X doesn't belong to B. It's very, very clear to us that X belongs to B complement. Whenever it doesn't belong to a set, it will definitely belong to the complement. That's how the complement is defined. So X belongs to B complement. Now, when we look at the set and the subset, like if A is a subset of B, then automatically the complements, they change places, they become less. So therefore, like B complement, since B complement is a subset of A complement. It's always like that. If A is a subset of B, then the complements, they change places, and B complement is a subset of A complement. Because B complement is a subset of A complement, if there is some element belonging to the smaller collection, it will definitely belong to the bigger collection. So therefore, I will get the continuation over here. Therefore, X will definitely belong to A complement. Because it is belonging to B complement, it will definitely belong to A complement. And once X belongs to A complement, it cannot belong to A. So that is what they have asked us. Therefore, X cannot belong to A. Why? Because it's already belonging to A complement.